So it's a start recording. Can you see?
Yes.
Yes.
Okay. So the address to reach at D location is 110. Huh? Now, what is our complete string? Complete string is, now what is the next digit?
It's 1.
1. Okay. So I am at D. Which route I need to follow? I should go to the 0 side or the 1 side?
One side.
Yes, 1. If I choose this way, this path, where I will reach?
To the A side.
To E. Yes. Next. So what is the address to reach at E? From
One
the
one
beginning?
01.
1101. Very good. Now E has two paths, one towards 0 and one side. So the address which I am following, the complete map, has
One.
11011. So I need to go to the 0 or I need to go to the 1
To
side.
the
1 or 0. Which one I choose?
1.
1. Okay. So if I choose this one, but where I will go? I don't know.
To A.
Where? Huh?
To A.
A. Very good. Why?
Because it's the first element. It's look like a cylinder.
No, it's like non-overlap. If you remember what I explained you last week, non-overlap means we need to start from the beginning again.
Oh, okay.
So when there is a non-overlap case and your string is complete, you got 11011, means your output is 1 here. If you remember, I explained last week. Output is 1, then you can go to the A, because it is non-overlap case. So always non-overlap case, whenever your string will complete, you need to go to the A, initial stage.
Okay.
Got it?
Here we go to the initial. So we will start again from A.
Yes,
So we put
again.
the whole
Yes,
code.
yeah. Got it?
Yes.
Okay. Now I will draw in clean diagram. So I want to erase. Can I? The clean, which you can do easily, yeah? Okay.
Yes.
So I'm showing you now. So how many digits in this string, girls, which we want to draw the state diagram?
It's
How
5
many digits? 5 digits. So how many states will exist? 5. We know that. A, B, C, D, and E. And now A is initial stage. What is the sequence we need to complete? 11011. So A to B, 1, B to C, again 1. So A is initial, B is 1, C is 1 1. And for D, 0. For E, 1. And when 1, it will go to the A because it is non-overlap case. Clear, girls?
Yes.
Okay, so here I am getting output 1, and everywhere I will get output 0 because no string complete, no complete. So I didn't get the output. Only I will get the output at this stage. Clear to everyone?
Yes.
Okay, now what are the remaining paths are left? We will complete that one now. Got it? So at each stage means at each location or at each station, we have 2 paths. So for the A, we follow one path. Which path is left for the A, which we didn't follow?
0.
0 path. So let's check. If I follow this path, where I will go? Understand? Now I need to check all paths. Means if I choose 0, if I go to the, if I choose one path, I will reach to the B. It's okay because, but if I choose 0, where I will go then? Let's start. So you will write at A, What is the path? 0. So do you have out of these 5 it states 5 location any value 0?
No.
Check these. Any value
D.
0 do you have?
D.
Which value is 0 here? 0
Next.
I mentioned
A.
A. So if A is 0, where it will go?
Loop.
1.
Itself. So if you choose one path, means if you choose this, you will reach to the B. But if you go to the 0 path, you will come back at A. Got it?
Yes.
Now next, at B. Which path we didn't complete? We left. One side, you will reach to the C. What is left here which we didn't
0.
follow? Which 0 path? We didn't follow. So if we follow the 0, 1, so at B, how will you follow this 0, girls? Always start from the beginning. How did you reach this? How did you reach here? First, you start your car from A, you follow this path 1 and then 0. So 1, 0. Clear or not? Okay. So 1, 0. Do you have complete sequence here out of these 5 states A, B, C, D, E? Any value of 1, 0 here? Check. Out of these 5, any value is 1, 0 here?
Maybe D.
No, B is 1. I am talking about 1, 0.
No.
If you don't have 1, 0, then leave this one and check 0 stage. Do you have any 0 stage?
A.
Yes.
A. So where it will go now?
A.
A. Clear?
Yes.
Okay. Now at C, which path we didn't complete? 0 we completed. If 1, then where it will go?
B.
So let's check at C. So how did you reach here? What is the sequence you need to follow?
1, 1.
Only 1, 1. Check. 1, 1, and then 1. 3 ones from the beginning. 1, then this one, then this one. How many ones?
3.
3 ones. 3 ones are available in these 5?
No.
No. So check 2 ones. 2 ones are available?
Yes.
Where?
Let's
So
see.
where it will go? Clear?
Miss,
Hmm?
why did I say 3 once?
Look, I can show. Rami. Mhm. Coupling to go. Shut the door properly. Here, listen. How did you check what is the path for C? Look, you need to start always from A. This is your car location. Clear? You start your journey from here. So you start your journey, then you are following this path. 1. Do you know you are not using plane? You will not directly go to the C location. You will go by car, by road. So if you start your car from your home at your home location from here, you need to follow this path 1. Then you need to follow this path 1 B to C. Then you will go this path. Got it?
Yes.
So at C, I have 3 ones. Understand now?
Yes.
If not, I can explain again. It should be clear to you. Is it clear or not? No?
Clear.
Okay. Now let's start. Which state is left at D?
110.
D, you finish one at D.
Yes.
Zero is left, huh?
Yes.
Yes.
So at D, how did you reach at zero location, girls? You need to start from the beginning. So
1 1
1,
0 0.
1, 0, 0. Do you have the complete sequence here available out of these five?
No,
No.
No. So you will choose 3.
100.
Is it available 100?
no.
Then choose 2 zeros are available.
No.
A,
If not 2 zeros, then single zero.
So A.
Single zero is A. Clear? So where you
Yes.
will go now?
To A.
To A. Clear?
Yes.
Okay. Now at E. So for E, which path you completed? For 1, which path is left? 0, 1. Let's start at E. How will you reach at 0 location?
1101.
1,
0.
1, 0,
0 0
1.
0.
No, 0, 1, 0. Don't forget. This is 1.
Yes.
Look, you choose this 1, 1, 0, 1, then
Yes.
0.
Yeah.
So do you have complete sequence available here?
No.
Then this 4,
Also no.
then this 3,
No.
then this 2,
No.
then the last.
A.
A,
So it will go to the
A.
clear or not.
Yes.
clear.
Okay. So take the screenshot. Then I will teach you overlap case for this. Interesting, girls?
Yes.
If it's clear, girls, I will explain now overlap case. Do you know everything will be same? Everything. I need your full attention, girls. Please listen me. Now I'm doing overlap case. For overlap case, look what are the changes I will made here. Okay, I will do yellow color. It's new color for you. So I will make it a little bit dark. Okay, so you can see it now. What I will do, girls, for the overlap case, whenever I got output 1, I will delete this case because only the changes will occur whenever I completed my string, whenever I am getting output 1. So where I am getting output 1 in this diagram? Tell me.
At B. Oh, no, at E.
No, output 1. I'm talking about output 1. Everywhere you are getting 0, everywhere except this E. Clear?
Okay.
So what I will do? I will remove this only. Everything will be same. Okay. Now, because it is overlap, so it will go in between somewhere. Let's check where it will go. So at E, if I am following this one path, then what will be the string, girls, for one path from the beginning?
1 1 0 1 1.
Yes, correct. Okay. So do you have complete sequence anywhere out of these 5 states?
No.
Check this 4.
No.
1 1 0 1 1. No. Then check these 3.
No.
Then check these 2.
Yes, there is C.
Where? C. So means where you will go for overlap case?
C.
To the C. That's it. Only this is the changes for overlap and non-overlap. For non-overlap, you will close your eyes and you can go to the initial because it is non-overlap case. But for overlap case, you need to find the way where it should go. It can go to the A also, or it can go any stage. It can go to the A, B, C, D, E based on the data which you will receive from here. Got it?
Yes.
For overlap case and non-overlap case, only one difference. For non-overlap case, whenever you are getting output 1, you will start from the initial. But for overlap case, you need to do these things and maybe you can go to any stage. It's not sure that you will always go to C, always go to D, always go to B, always go to A, any state I can go. Clear?
Yes.
That is the main difference between overlap and non-overlap. Got it? Could you try one question? I can give it to you.
Yes.
Okay. So the sequence which I am giving you now, which you have to do, the sequence is this. Let me delete this. And first draw non-overlap case, then overlap. So sequence I am giving 101 to you. First draw non-overlap. Okay. Clear?
Yes. Yes.
Okay. Okay. So registers, what is register? What will be the definition for register? The register, you will say it is an extension of a flip-flop, can store multiple bits, because you know that flip-flop store one bit at one time, but one bit will not be sufficient for us, so we need to use more number of flip-flop. That's why when we use more number of flip-flop, we will not say that we are using 4 flip-flop. No, we will say 4-bit register. Got it?
Yes.
And what are the advantage of this? It's mentioned here. They are faster and more convention than main memory. More register can help speed the complex calculation. Girls, if you see CPU, you know, you will find nearby CPU so many registers. So it plays very important role. Okay. So this is, of course, you need to save something. You need memory. Memory comes from flip-flop, and number of flip-flops, when you combine, it comes register. So you know the importance of this. It's very advantageous. Now the next, yeah, here. So how many flip-flop you can see in this diagram, girls?
4.
4.
Four. So this is 4-bit register. Now, could you tell me the clock is same or different?
Same.
Same. So that's why it is called synchronized. Okay, means all will work together. And which flip-flop they use here?
D.
D flip-flop.
D flip-flop. What is the truth table for D flip-flop? If D is 0, what is the output?
0. Same.
Same. If D is 1,
1.
1. Okay. Now we will draw the waveform for this. Let's start. Sorry. So what will be the waveform? Here. This is the clock, means result will change here, here. Okay. I need to draw A0, A1, A2, A3. They have given inputs already. So different input for each flip-flop. So I am going to first draw, because first is I3. So I will draw first A3. The remaining you can do yourself. Huh? Now, before the clock, here is no clock. Before the clock, what will be A3?
0.
0. So that's why here it's 0. Now this is the time where result will change. So I need to check I3. When I check I3, can you see girls here the I3 value at the same clock? You can see first it is 0 and then 1. Means I3 values is changing at the edge of the clock. Can you notice this?
Yes.
But if you see I2, can you see I2? I2 is with the clock, it is 1. It's clear. I1 is 0 here. It's clear. But what is the case for I3?
Change.
Change. It is changing from 0 to 1. So I need to choose either 1 or 0. Which value I need to choose? How will you decide? Because there are two values at the edge. Give me suggestion. Which value you can choose in that case?
1.
1. Any other girl? Always you have two options, either 1 or 0. Listen, if you have this case, girls, always choose the first value. Hello, girls.
Hello.
Yeah, and there was internet problem. So it's stop. So yeah, we're discussing this shift register. No, register only. So here now you can see what I told you. If you have this case that you are giving the clock and at the edge of the clock, two value change of any input from 0 to 1 like this. Means you don't have a clear that it should be 0 or 1. So then you need to choose the first value. What is the first value here? Tell me
1.
how.
0.
You cannot decide which value is first. How is it 1?
0.
Yeah, first value from 0 to 1 it is. So first value is 0, not 1. Got it?
Yes.
Okay. So I3 before the clock, of course, A3 will be 0. Now you can check at the edge of the clock, the first value is 0. So I will consider 0 and it will continue till next clock. Got it?
Yes.
Hello?
Yes.
Yes.
Okay. Now again time to change the in result. So you can see this is the age of the clock. And now check the value of I3. I3 is 1 first and then 0. So which value you will choose now?
1.
1. So result will go to 1 and 1 till to the next clock. Now, now check the value of I3 again. What is the value of I3? It is 0 and then 1. So which value you will choose now?
0.
Same you can complete for others. For I2, I1, I0. Got it? Anyone has doubt in this? Hello? So whenever this happen, you need to choose the first value. Got it, girls?
Yes, yes.
Yes.
Okay. Now we are talking about shift register. Shift register, from the name you can understand shifting. So there are four, here it is 4-bit register. So there are 4 flip-flops and shift. So there will be shifting occurs. It is right shift register. So the bits will shift to the right side. Okay. You will give data here, enter, the data will enter from here, whatever you want to give, like 1101. If then this will go first one here, then this one will be the input of this. So this one will go here. So next digit will come, then 0. Then this one will shift here. So 0 will here, then next one will be here. So shifting will occur, right shifting. So this is called right shift register. Got it?
Yes.
I will explain here with the example. Look, after that I will explain first this example. So here in this you can see that we have here 4 flip-flop. Okay. And 4 flip-flop and data I need to save here 1011. But it is shift register, so shifting will occur, and this is right shift register, so right shifting will occur here. So this is your data 1011. So you will choose first this LSB. Okay, this digit. So this first digit will enter here, and this will save in first flip flop, and the others will be empty now. Got it?
Yes.
But it will work with the clock. If you don't give clock, it will not work. You know that flip flop works with the clock. Got it? So always we mention here clock pulse, means we are giving the clock. Got it, girls?
Yes.
Okay, now the next digit is 1. So 1 will enter here. And what happened with this one, girls? There is a right
Shift.
shifting. So we, yes, shift to the next. Got it?
Yes.
Okay. Now the next digit is 0. Next input. So 0 will be here. And what will happen with these two? It
They
will
will shift to the right.
shift. Yeah, right side, because it is right shift register. Then next, it is 1. And this 0 will be here, this one will be here, and this. So now all flip flops are occupied, and this is the data which we want to save. Okay,
Yes.
got it, girls? Now data, I have this data, and this data is only 4-bit. Clear? So now data bits finish, but I am giving clock. So as you know, it is right shift register. So of course shifting will occur. But what will happen? Because I'm not giving any data digit now here. So what will happen? This one will shift here. This 0 will shift here. This one will shift here. And this one will go Clear?
Yes, it will.
Yes.
Got it? Because it is shift register, right? Shift register. So whenever you will give the clock, of course, shifting will occur. But as you are not giving any input data, so there will be no digit, no data will enter. Only whatever is stored already, shifting will occur with that data. Got it?
Yes.
Yes.
It's clear.
Okay. So I hope that you understand the concept of shift register.
Yes.
Yes.
Okay.
Clear.
So shifting can occur right side. Similarly, if I entered from this side, so shifting will occur to the left side also. So right shifting, left shifting, based on the requirement we can do. Okay, girls?
Yes.
Okay. Now we will do the waveform for the shift register. Let's start waveform here. So this is the clock. Now SI is the input, serial input, and we need to plot first. We need to draw the waveform for Q3. Let's start, girls. So before the clock, what will be the result? The initial value will be 0. Got it?
Yes.
Okay. Now at the edge of the clock, you can see it is 0 and 1. So which value you will choose?
First value.
First value is,
0.
so I will choose 0. It will continue 0. Then here again it will change. So 1 and 0. So which value I will choose?
1.
1.
Now here, what is the data?
0, 0. So I will choose 0.
0. Now here,
0, 1, 0.
Here.
0. Clear, girls?
Yes.
Now I want to plot the waveform for Q2. For Q2, which one is the input? Is this SI?
No, Q3.
No.
Yes. Now Q3 is the input, so you need to follow Q3. So before the clock, of course, 0. Now at the edge of the clock, you can see the result is 0. So of course it will be 0. Now this is 0 and 1. So what will be the result?
0.
0.
0. Now here, this is from 1 to 0. So what will be the output now in this case?
1.
1. And here, what is the input now here?
0, 0.
0. Why 0, 0? You should say only 0.
Okay.
We don't have two input. We have only one input. Okay. So this is one input. So it is 0 only. So 0. So it will go to 0. Now you can see for Q1. What is the input for Q1?
Q2.
Q2.
Q2. Similarly for Q0, what is the input for Q0?
Q1.
Q1. So this is called shift register. Got it, girls?
Yes.
Girls, I updated the slide, and this slide I will upload on Blackboard. So we will not study this, not this, even not this. Okay, now you will do this example. You will do yourself. Try it. Everybody has to try this question. Try to understand what is the question, girls. Can you read it? Hello? Hello? Who will read this question? You cannot read, girls. Speak.
4-bit register
Hello?
has
Yeah,
1, 1,
4-bit register. So 4 blocks. Then,
has 1101 initially.
so what do you mean by this? Is it empty?
No, it's start.
It has?
1101.
Yeah, that means initial value, it has this 1101. So this is the initial value. So we cannot say that initially it is clear. No, it is not clear. It has some data. Then what they want? They want 4 shifting, means 4 clock. 1 clock, 2 clock, 3 clock, 4 clock. Okay. And what is the data they want to shift? Data is this 0110. Now it start. What will be your answer after 4 clock? What is the answer after 4th clock, girls?
Same.
Hmm? What is the
Same
answer?
as same as the initial value. Bits 1101.
1101. Hmm. What are you getting, other girls? Girl, what is your answer?
The same initial value.
Okay, so you got 1101. Fine.
Yeah.
So now, girls, we have done the registers. No need to do this. No need to do this. I mean, no need to do this. Now start the counters. So we need to learn now this counter. Very important topic and very interesting also. Girls, when you heard the name counter, what do you understand from this name? Counter means what?
Memory.
Please.
Accumulate.
It's a sequential circuit we are studying, so of course memory will be there, of course, because it's I am asking about the name. When you heard the name, what concept, what do you think about that? That it will be which type, or what do you mean by counters? Any idea, girls? Please count from where it comes, the name. Hello, are you sleeping, girls?
Maybe count something. Repetition.
The name, I'm asking from the name. Counters. So it comes from count, means counting something. Got it?
Yes. Yes.
So counters means for counting. And girls, of course, it's sequential circuit. So it has memory also. Yes. So counters, girls, for counting purpose, what are the use of the counters? For timing, like if you, for clock, we have the countings, and sequencing, like if I have 2 3 things I need to synchronize all together, I can place their counter, so it will start after 5 minutes or 10 minutes at the same time, all will work. Similarly for counting purpose, so there are so many uses for the counter which we are studying, so we use in our daily life. Okay, so let's start counters. Girls, if you see this state diagram, what is the new thing you notice here in this state diagram? What is the new thing you notice here?
Square.
Hmm?
No output.
No output.
No output, and input is always
1.
1. So as
One.
you know, it is counter. So of course it will move from one value to next value 2, then next value 2 to another next value, then 3 to 4, and after 4 it will go back to 1 if we have only these stages. So counters always, girls, we have input for the counter. So input always be 1, there will be no 0. That's why for the counters, for this sequential circuit counters, there is no need to mention input and output. No need, because output is always 1, even input is always 1. For that, we are getting result from 1 to next stage all the time, and input is always 1. So no need to consider here inputs and output. Got it?
Yes.
Okay. And always for the counter, it will go back to 0. After the final stage, it will go back to 0 always, because it is counter. So whenever it will reach to the last stage, it will go to the initial. Got it?
Yes.
Yes.
Okay. So if I have this counter, it will go from 0, 0 to 0, 1, 0, 1 to 1, 0, 1, 0 to 1, 1, and 1, 1 to 1, 0. Now start the state table. If you want to draw the state table, you have present state and next state. So if you are at 0, 0, what will be the next?
0,
If you are at 0, 1, what is the next?
1 0
1, 0. If you are at 1, 0, what is the next?
1 1
And if you are at 1, 1, what is the next?
0 0.
That's it. No input, no output. Got it?
Yes.